Keeper 5.5 optimization. There are several steps needed to solve optimization problems. The first step that I put on here is kind of obvious, kind of self-explanatory, but you really do want to understand your problem. You need to know what you have, what you don't have, and what you're truly trying to find. Once you've done that, you can go ahead and draw a diagram and use this diagram to visualize what you want to see or what the problem is trying to tell you. I use drawings on almost every single picture or every single problem that I do to make sure that I really have a deep understanding of what it's saying and what it's asking for. Number three, you want to use proper notation. So if you're trying to find circumference, I would say like C. If I'm trying to find area, I use A versus surface area. Sometimes I use SA. Depending on what I'm working with, I want to make sure I'm labeling and defining those variables appropriately. Then you want to write your equations. And so generally you're going to use a known equation. 9 times out of 10 it's going to be some equation from like geometry or something like that. You want to use those equations and you want to write it in terms of one variable. So for instance, if you had a volume formula that was in terms of height and radius, you'd want to either get rid of the height or get rid of the radius by rewriting the equation. Next, you want to find relationships between the variables. Usually those relationships can be found in the statement. Usually they'll give you some other type of formula to use to find those relationships. You just have to pick it out of the scenario. And then lastly, you want to differentiate. And by differentiating, you're finding your max and your mins when you set it equal to 0. Example 1. Find two positive numbers such that their product is 192 and the sum of the first plus 3 times the second is a minimum. So the very first thing I'm going to do is go with what I know. I know, based off of this sentence, that the product of the two numbers is 192. So I'm going to call these two numbers x and y, and I'm going to say that I know x times y equals 192. Now, using this information, I'm going to solve for one variable. So for me, I just solve for x, and I say x equals 192 over y. The next, I'm going to go on to the second part of the sentence that says the sum of the first plus 3 times the second is a minimum. So the sum of the first, which would be my x, plus 3 times the second, which would be 3y, I know is going to give me a minimum. So again, once I get these equations, I don't want two variables. So I'm going to use my known to plug into what I have now to reduce it down to one variable. So in other words, I'm going to take this x, this 192 over y, and I'm going to plug it into this equation for x. And so instead of x plus 3y, I'm going to have 192 over y plus 3y. Now to find out what makes it a minimum, I have to find my derivative and set it equal to 0. So finding the derivative of this, the derivative of 192 over y is negative 192 over y squared, and then the derivative of 3y is 3. And so I have negative 192 over y squared plus 3 equals 0. I'm going to multiply the entire equation by y squared to get negative 192 plus 3y squared equals 0. I'm going to add 192 to both sides and divide by 3 to get y squared equals 64, which tells me that y must be 8. Now I'm already feeling like y equals 8 is the answer, but I need to verify that this is a minimum and not a maximum. So again, I'm going to draw out my f prime or my derivative line with 8 on it. I pick a number to the left of 8, let's say like 0, and plug it into my derivative. I get a negative answer. And then I plug in a number to the right of 8, which I could plug in like 9 or 10, something like that, and I get a positive number. Remember, you're plugging into the derivative. And so because I got a negative number, I'm decreasing, and then a positive number, so I'm increasing. If I'm going from decrease to increase, that means I have a minimum of my function. So that means the minimum value for y would be 8, and if I plug that 8 back into my x equals equation, 192 divided by 8 equals 24, and so I get y equals 8. That means x must equal 24. Okay, so Gardner wants to make a rectangular enclosure using a wall on one side and 120 feet of fencing on the other 3 sides. Express the area in terms of x and find the value of x that gives the greatest area. Very first thing I like to do is draw a picture. So here's my picture. I have the wall on one side. I have x on the top and the bottom because those are like parallel to my x-axis, so I use that as x. And then I put y on my vertical because that's parallel to the y-axis. Again, it doesn't really matter what variables you use where, just make sure you're consistent. Now, what they told us was that we had 120 meters of fencing, which means that for my entire perimeter, I can use 120 meters. Now, remember, I don't need fencing on my wall, so my perimeter is 2x plus y, and that's going to equal 120. Now, if I take that equation and solve for one of my variables, in this case, I'm going to solve for y because y is the easiest to solve for. I get y equals 120 minus 2x. Now, the actual problem is asking us for area, so I'm going to start with the area formula, and I have area equals x times y. Now, remember, I don't want to have two variables when trying to optimize, so what I'm going to do is I'm going to take out this y, and I'm going to replace it with this 120 minus 2x. So I get area equals x times 120 minus 2x. Now, if I distribute it in, I get area equals 120x minus 2x squared, and that is my area in terms of x. Now, if I want to find the x value that gives me the greatest area, I must optimize it, which means I have to find the derivative. So, finding the derivative, I get 120 minus 4x, and then I set that equal to 0 to get 4x equals 120, or I get x equals 30 meters. Now, again, I want to check to make sure that that is actually the greatest. In other words, I want to make sure that it's a maximum versus the minimum. So I create my number line. I plug in a number to the left of 30, so maybe like 0 or even 29, whatever you want to plug in. I notice I get a positive number, and then I plug in a number to the right of 30, I get a negative number. Now, because I'm increasing and then I'm decreasing, I'm going to end up with a maximum. And so that's what I wanted. They asked for the maximum x value that gives the maximum area. Since the x value is a maximum, I know x equals 30 meters is my answer. A person in a rowboat 2 miles from the nearest point on a straight shoreline wishes to reach a house 6 miles further down the shoreline. If the person could row at a rate of 3 miles per hour and walk at a rate of 5 miles per hour, find the least amount of time required to reach the house. How far from the house should the person land the rowboat? All right, so the idea of what's going on here is this person is trying to figure out how far should I row, how far should I walk to get to this house in the least amount of time. So I'm going to start by labeling some things. So the first thing I'm going to label is this piece right here. I'm going to label that X. Next, if that is X and the whole piece is 6, then the remaining part is going to be 6 minus X. Now I can also find this diagonal piece using Pythagoras theorem since I have a triangle, and so I get square root of x squared plus 2 squared, or x squared plus 4. Alright, now you have to remember your formulas. Some of you guys might not remember this, but you need to remember the formula that distance equals rate times time. Now, if I take this formula and solve for time, since we're trying to find the least amount of time, I get time equals distance over rate. Alright, so my total time in this case would be the total time for rowing plus the total time of walking. Alright, so my total time for rowing is the square root of x squared plus 4 over 3. And so that's this piece right here, the x squared plus 4 over the rate, which was 3 miles per hour. And then my total time for walking is 6 minus x over 5, which again was this piece right here over the 5 miles per hour. And so what I'm going to do there is next is I'm going to take my derivative and I'm going to set it equal to 0. Now I could do this by hand, but I choose not to because this would definitely be a calculator question on the exam. So what I'm going to do is take my calculator and tell it to solve the function. So plug in my function, set it equal to 0 and tell it to solve for x. Once I do that, I get that x equals 3 over 2 miles. In other words, I need this piece right here to be 3 over 2. Alright, so then they want to know, or they really ask what's the least amount of time. So if I plug in that 3 over 2 into my formula, I get 1.733, and that should actually say hours. 1.733 hours for time.